Okay, so now you have to watch your language
Huh.
because you'll be on YouTube.
We don't want your channel getting points stopped on it.
I think I'm up to 19 subscribers,
All right.
and few people are watching them. Okay.
Besides the NSA?
Is what?
Besides the NSA?
Well, they don't tell you they're watching. Practical circuits, it covers three groups, so there's three exam questions. There's about a dozen questions, full questions for each one of the groups. So we'll cover, I guess they took out power supplies from the previous one. Schematic symbols, going to digital circuits, amplifiers, oscillators, receivers and transmitters, and the other components you need. So we'll start off with one of their schematics. This is what's on the exam. So we'll go through them. And number one is a field effect transistor, which turn that one on. Then number two is a bipolar transistor. Three is a diode. This is a normal p-n junction diode. Then they threw in a varactor diode, which you probably haven't heard of, which turns out when you reverse bias a diode, it appears capacitive and it will change depending on the bias voltage. So you can use it as a voltage variable capacitor. Five is a Zener diode, which has this sort of Z shape to it. And that's also used in reverse. And in this case, they control the reverse breakdown voltage. So you can get these for, say, a 5-volt one, which means whenever the voltage on the cathode with respect to the anode was 5 volts or greater, it would conduct. So you can use that as a simple voltage regulator with just a series resistor. Number 6 is our solid core transformer. And those vertical lines are representing the core. We have a primary and a secondary. The way it's drawn, it's showing a step-down transformer, where you have more windings on the primary than you do on the secondary. Number 7 is a tapped inductor. Ooh, I didn't let go of the mouse. This also, the way it's shown here, could be called an auto transformer. So depending on where this tap is, the number of turns between this end and the tap compared to the total number of turns will give you the turns ratio of that. So in this case, it would be a step-up auto transformer as far as this pointed right there.
Which is commonly used in
all kinds of things. What?
unknown.
Oh, unknowns. Yes. Matching transformers will normally be configured as an auto transformer as opposed to two separate windings. We got capacitors, number 8. It turns out there's a bunch of them on here, but they only care about, where's number 8? And these symbols are all the same. Sometimes you will see a different symbol if it's an electrolytic capacitor. They don't put those on the test. Then we have our ubiquitous resistors, and there's all over the place. So number 9, and those symbols are all the same. The only time you might see a difference is a variable resistor. or a potentiometer, where it'll have a tap or a line through it showing that it's variable. Oh, and there's a potentiometer. Where's 11?
At the top of the top.
Oh, there it is. In this case, you're using all three leads. So if you had and the reason they call it a potentiometer is there's a voltage across it where you move the center lead will give you a proportion of that voltage, assuming that you've got the impedances right where the current's not affecting it. Okay, so I guess I got to turn that one off. Let's try some. Which symbol represents a field effect transistor?
Dosing. Number one. C, Charlie.
Charlie. Absolutely.
Ah,
And that's actually a junction FET, the way they're showing it, as opposed to a MOSFET. Which symbol represents a Zener diode?
Delta. Yeah.
Yeah.
Which symbol represents an NPN junction transistor?
Dose. Bueno.
And why is that an NPN? Because the little arrow down here on the emitter is pointing out. So it means that the base would be a P junction and the emitter would be an N material. And then the collector is also going to be an N. So it would be an NPN. Which symbol represents a solid core transformer?
Cocabera.
Oh, there we go.
Charlie.
Charlie. Okay. Which symbol represents a tapped inductor?
Alpha.
Okay. Half-wave rectifiers are used in very simple power supply circuits typically. It has one diode, which we call a rectifier because that's the function it's doing. It's rectifying the AC to DC. In the olden days, they used to make special components that were used as rectifiers. Some of them were a stack of selenium plates that only conducted one way and handled a lot of power. There were some other forms of them. Now, they're almost always a solid state diode.
Bridge rectifier with big heat sinks on it.
Yeah. The key point here is that it only conducts on 1/2 or 180 degrees of the AC cycle. So we got our AC signal coming in on the primary. We get a lower voltage version of that on the secondary, assuming this is a step-down transformer, which it says it is. And what we get out of or through the diode are the positive peaks. So we have a pulsing DC at the frequency of the input. So if this is 60 cycles, we're going to get 60 pulses per second coming out in the positive direction. And remember, this is all RMS. So if this was 12 volts RMS, then these are going to be 12 volt RMS pulses. And if you'd filter it, you're going to wind up approximately 12 volts DC. And also the other key thing for a half-wave rectifier, you only need one diode. I'm not sure why they make a big deal about that. Diodes are so cheap. but it's a test question. What portion of the AC cycle is converted to DC by a half-wave rectifier? Very good. Now we have a full wave. The difference is it uses two diodes. It converts the entire waveform, or 360 degrees, and we get twice as many DC pulses, so there are twice the input frequency. It does require two diodes to do it, plus you need a center tap transformer. So if I still wanted this to be 12 volts out, I'd need a 24 volt center tap transformer. So basically I have 12 volts on either side. So this one conducts on 1/2 cycle. This one conducts on the opposite half cycle. Then we have a full wave bridge rectifier, which behaves the same. The difference is it takes 4 diodes, and we're back to a non-center tap transformer. So this could still be a 12 volt transformer, and we get 12 volts out at twice the frequency. What portion of the AC cycle is converted to DC by a full wave rectifier? Delta. What is characteristic of a half wave rectifier in a power supply?
Alente?
What?
Alente.
I'm not good on Spanish.
Oh,
Or was that Italian?
I have no idea. Allegro would be Italian.
Okay,
Alpha.
alpha. Which type of rectifier circuit uses two diodes and a center tap transformer?
Oh. Cocavera.
Charlie. I'll translate for him if I can.
What's your answer?
Charlie.
Charlie?
Judging by that look, you're giving me which I know. Oh, but so well. I'm wrong.
Yeah. Two diodes and a center tap transformer. What was the only one that used the center tap transformer?
Alpha. He's Alpha modelers, so we'll say Alpha.
Right.
We're dying.
Because they throw in two diodes. So it can't be a full wave bridge because that takes 4 diodes. And it doesn't require center tap transformer. And the half wave is a single diode and a regular transformer. And synchronous in this case means nothing. What is the output waveform of an unfiltered full wave rectifier connected to a resistive load? So it's going into a pure resistor, so we don't have any reactance or anything going on.
Alpha. I'll go with Alente or Allegro too.
Alpha sounds good to me. Okay, we got two kinds of power supplies, typically. Linear, which have been around forever, where you have a transformer, you step the voltage up or down. In old tube equipment, this would normally be a step-up transformer because you want to generate several hundred volts for the output tubes on the transmitter. In this case, we're going through a bridge rectifier. So we're getting DC pulses at this point. That kind of waveform. There's a filter capacitor. Sometimes this could be multiple capacitors in parallel and possibly a series inductor to help filter this out, depending on how clean they want the signal to be. These transistors are kind of a helper circuit for this integrated voltage regulator. Normally, these only go up to maybe an amp or less. So in this case, they want 12 volts at 5 amps out. So they use this regulator as kind of a control function, and you get all the current and voltage regulation through these two transistors. So this is actually controlling how much those two turn on. And then we have some output filtering, which again could be multiple capacitors and an inductor. They're showing a resistor across here they call a load. That would also be called a bleeder resistor, and its purpose is when you turn the power supply off, it will discharge these output capacitors. If this is a 12-volt supply, it isn't nearly as much as a problem, but if this was a 350-volt supply, you don't want to touch that output lead. Go work on it and find out that the capacitors still have a charge.
The other safety feature is a fuse on the primary.
And a fuse on the primary. And a kill switch. So which of the following components are used in a power supply filter network?
Delta.
Byron?
Ooh. And Donald don't to be there with it.
That was an inductor. So
Oh, power supply.
it says the filter network.
Oh.
So
I'll say
no diodes, right?
just the filter network.
And there's no transformer in the filter network.
Charlotte. Yeah.
So it's Charlie. What is the function of a power supply bleeder resistor?
Bravo.
Okay, the other type, which is much more current, are switching supplies. They're today usually cheaper for the same amount of power output. They're smaller. The only disadvantage is you may have some noise coming out of it due to the high frequencies. And the way they work is you take your input or mains voltage. I think whoever did that diagram was British, because we don't call them mains. You rectify your input voltage without a transformer. So you'd have say you had 120 volts coming in, you're going to rectify and filter that and wind up with 120 volt RMS or DC rather. Then it goes through what they're calling a chopper or inverter, where you're converting that to a pulse width modulated signal depending on the output voltage that you're seeing, and that's how it regulates. If you had this set for, say, 100 volts.
The pulse width modulator, does that mean something like amateur radio irritator?
Could be. It means that it converts it to pulses whose width is proportional to the amount of voltage that you want out. Okay, because you're going to take the area under the curve, basically smooth those pulses. So if you wanted the full output, basically you're going to have almost 100% duty cycle. Now, the reason that you chop that up is you're converting it back to a square wave, okay, so that you can run it through a transformer where the DC wouldn't work. So now you've got a a DC square wave whose pulse widths are proportional to the amount of voltage you want on the output. And that's due to that feedback circuit. So then after you go through the output transformer where you're either stepping it up or stepping it down, you rectify that back to a DC voltage and filter it. It's a lot more complicated, a lot more components, but you normally do the inverter up in the 200, 500 kilohertz range. So your transformer, which is usually a small ferrite toroid, can be very small, and the whole thing can be almost hold it in your hand for a typical amateur radio 30-volt power supply. The main advantage is that high frequency operation allows you to use all these small components. You need smaller capacitors to filter it because of the frequency. Which of the following is characteristic of a switch mode power supply compared to a linear power supply?
Charlie?
Okay.
I think on this one, Bob, it's C.
Huh?
I think on this screen, it's C.